Welcome to this video on grades 8 to 9 revision set A. Remember to like and subscribe for more videos like this. Question 1 says, here are the first 5 terms of a quadratic sequence. We've got 3, 5, 8, 12 and 17. We need to write down the nth term of this sequence. So the first step is to find out what the common difference is between each of the terms. The difference between 3 and 5 is plus 2. The difference between 5 and 8 is plus 3. The difference between 8 and 12 is plus 4. And the difference between 12 and 17 is plus 5. Now, since these differences are all different, we need to find the next difference between each of the terms. So the next difference, they're all going up by 1. Now we've got 3 formulas to remember when we're doing the quadratic nth term. 2a is always equal to the first number of the last sequence. 3a plus b is always equal to the first number of the second sequence. And a plus b plus c is always equal to the first number in the first sequence. And then we work from the bottom upwards. So if 2a is equal to 1, then that means a is equal to a half. If 3a plus b is equal to 2, and we know that a is equal to a half, 3 times a half is 1.5, plus b equals 2. If we subtract 1.5 from both sides, b is therefore equal to a half. So we've got a and we've got b. And we know that a plus b plus c is equal to 3. We know that a is a half plus b, which is a half, plus c equals 3. A half plus a half is equal to 1 plus c equals 3. Subtracting 1 from both sides, c is equal to 2. So the quadratic nth term is always written in the form an squared plus bn plus c. So a is a half, so it's a half n squared, b is a half plus a half n, and c is 2. So this is our final answer. Question 2 says, by completing the square, find the turning point of the graph with the equation y equals x squared minus x plus 10. So to complete the square, we first draw our brackets out and then a squared sign outside of the bracket. Inside of the brackets first, we're going to look at the variable that we're considering. In this case, we're considering x's. Next, we're going to half the number in the middle. So technically, this is negative 1. So half of negative 1 is equal to negative a half. And then we're going to subtract the square of the number inside of the bracket. So we're going to subtract negative a half squared. And next, we're going to add this number on at the end. So we've got x minus a half all squared, and then we've got minus a half squared plus 10. So I'm going to do this on the calculator. We're going to get negative a half squared plus 10. So this is equal to 39 over 4. So plus 39 over 4. And the coordinates of the turning point, we change the sign of the number inside, so it's going to be a half, and we keep the number outside, so 39 over 4. So if we want this in decimal format, we can press SD. This is 9.75, and a half is 0.5. So that is the coordinate point of the turning point. Question 3 says, solve the simultaneous equations. We've got x squared plus y squared equals 16. And we've got 2x plus y equals 8. So the first thing to do when we're looking at quadratic simultaneous equations is we need to make the linear equation that we're given equal to either x or y. So in this case, I'm going to make it equal to y. So to make it equal to y, I'm going to minus 2x from both sides, and this gives me y equals 8 minus 2x. And then we substitute this into the first equation. So we've got x squared, and then we've got plus y squared. Well, y is 8 minus 2x, so plus 8 minus 2x all squared equals 16. So next we're going to expand this bracket out. This is 8 minus 2x times 8 minus 2x, and this is equal to 16. And if we expand that double bracket out, we're going to get plus 4x squared minus 32x plus 64, and this is equal to 16. So x squared plus 4x squared is 5x squared. Then we've got minus 32x, and then 64 subtract 16 is equal to 48. So plus 48, and this is equal to 0. So now we're in a position where we can solve the equation for x. Now on the calculator, you can do this very quickly. You can either do the quadratic formula, which you would have to show your workings out in the exam, or you can go to equation and function, then select 2, which is polynomial. The degree is 2 because it's a quadratic, and then we put in our numbers, so 5 minus 32 and 48. So this gives us that x is equal to 4, or if we press equals again, x is equal to 12 over 5. So in the exam, like I say, you need to do the quadratic formula and show your workings, but this is a useful calculator way to show that you've got the answers correct. So if x is equal to 4 and x is equal to 12 over 5, we can substitute this back into this y equals 8 minus 2x formula. So if y is equal to 8 minus 2 times, let's look at 4 first, y is equal to 8 minus 8, which is 0. So when x is equal to 4, y is equal to 0, and when x is equal to 12 over 5, if we do y equals 8 minus 2 times 12 over 5, put this into the calculator, go back to menu setup and to 1, 8 minus 2 times 12 over 5, and this is equal to 16 over 5. So those are our final answers. Question 4 says, prove that the sum of squares of any two consecutive integers is always an odd number. So two consecutive integers could be n and n plus 1, and we need to prove that the sum of the squares, so if we square these and add them together, we're going to get n squared plus n plus 1 times n plus 1. This is n squared plus, and if we expand this double bracket, we get n squared plus 2n plus 1. This simplifies to give us 2n squared plus 2n plus 1. We can take a factor of 2 out to the front to get 2 brackets n squared plus n plus 1. Now anything times 2 is always even, and then if we add 1 to that value, this will equal an odd number. Question 5 says solve x squared minus 2x minus 2 is greater than or equal to 0. So first we're going to look at x squared minus 2x minus 2 equals 0. So we're going to replace the inequality with an equal sign. And we're going to use this trick on the calculator to find the values for x when we solve this quadratic. But like I said in the previous question, we need to show our workings using the quadratic formula. So we've got 1 for x squared, minus 2 for the x coefficient, and then minus 2. So this gives us x, which is equal to 1 plus root 3, or if we press equals again, we'll get the other x value, 1 minus root 3. So 1 plus root 3, or 1 minus root 3, is equal to negative 0.73, and 1 plus root 3 is equal to 2.73. So if we look at these points on a graph and we roughly sketch the graph x squared minus 2x minus 2, these points here are the roots, so where they cross the x-axis. So if 2.73 is about here and we say negative 0.73 is about there, we can draw a curve through these points. So the graph will roughly look like that. And we're looking for when the equation is greater than or equal to 0. So if this is the 0 line here, this x-axis, we're looking for all of the solutions that are greater than or equal to this equation. So that means we're interested in these portions of the graph. So if we were to continue extending this line up the page, we'd see that we're interested in all of the solutions from that point, which is minus 0.73, all the solutions to the left of that, and this point is 2.73, which means we're interested in all of the points that side. So the solution that we're going to write is either x is less than, so x is less than or equal to minus 0.73, or x is greater than or equal to 2.73. And these two inequalities are our final answer. Question 6 says, sketch the graph for y equals tan of x between 0 and 360 degrees. So first I'm going to draw the axes. It goes between 1 and -1, and the important points are 90, 180, 270 and 360. So first the graph goes up like this, and then we draw our asymptote, and then we draw our next curve, and then another asymptote, and then we go just up to 360. So that is the graph for y equals tan of x. Question 7 says, simplify fully 2x plus 6 over x minus 3 divided by 2x squared plus 7x plus 3 all over x squared minus 9. So when we're dividing fractions, it's keep, change, flip. So we're going to keep the first fraction, change the sign from a division sign to a multiplication sign, and then flip the fraction. So x squared minus 9 all over 2x squared plus 7x plus 3. Now we're going to simplify and factorize. So we're going to factorize 2x plus 6, which is 2 brackets x plus 3, then over x minus 3, multiplied by, so this next bit is a difference of two squares. So this can be simplified to give us x minus 3, x plus 3, all over, and then we can factorize this here. So 2x squared plus 7x plus 3. We can use MAFS to factorize. Our m value is the number in front times the end number, which is 6. The a number is the number in the middle, which is 7. And we think of two numbers that multiply together to give us 6 and add together to give us 7. So these two numbers are 6 and 1. Next we write out the first term, which is 2x squared, and the last term, which is plus 3. And we fill in the middle terms here with the two numbers that we've just found. So we've got plus 6, and we stick the algebra on at the end, which is x, and then plus 1x. Next we split the equation in half. We've got 2x squared plus 6x. We can bring a factor of 2x out to the front, and then inside have x plus 3. Then bring a factor of 1 out to the front, and then inside have x plus 3. So the two brackets will be 2x plus 1 from this section here, and x plus 3. So we've got x plus 3 and 2x plus 1. Now since this is multiplication, we can combine everything on the numerator. So 2 brackets x plus 3 times by x minus 3 times by x plus 3 all over x minus 3 times x plus 3 times 2x plus 1. So we can cancel out x minus 3, x minus 3, x plus 3, x plus 3, and we're left with 2 brackets x plus 3 all over 2x plus 1. We can actually expand this back out to give us 2x plus 6 over 2x plus 1. The 2x's cancel on top and bottom, so we're left with 6 over 1, which is just equal to 6. So that is the final answer. So this concludes grades 8 to 9 revision set A. Remember to like and subscribe to the channel for more videos like this.